Hello students, I am Professor Navneet Kaur from EC Department, SIRT College, Bhopal. Today I'll be taking lecture on subject digital communication. In this lecture, I'll be discussing the topic bipolar encoding techniques. In this lecture, I will discuss the various types of bipolar encoding techniques, their advantages and their disadvantages. Now first, we will understand the meaning of line encoding. As discussed in my previous lecture also, line encoding is the method of changing the digital data into digital signal. We must encode data into signals to send from one place to another, and for that, line encoding method is used. For converting one mode of signal to another mode, we have different conversion methods. First is digital to digital encoding, another is analog to digital encoding, then digital to analog encoding, and analog to analog encoding method. For example, digital to digital encoding method is described by the line encoding method, which is described in this lecture. Analog to digital encoding method like pulse code modulation, delta modulation, in which analog data is converted into the digital data. Digital to analog conversion method is the digital modulation techniques like BPSK, QPSK, PFSK, and so on. And analog to analog conversion method is like analog modulation methods like amplitude modulation, frequency modulation, phase modulation. Now, in this lecture, we are doing digital to digital conversion method. So, as already discussed, digital to digital encoding in which the digital data is converted into the form of a voltage signals where bit can be represented by positive pulse, negative pulse, or zero level. Now, digital to digital encoding is categorized into three categories: unipolar, polar, and bipolar. In my previous lecture, I have already discussed first two methods, that is unipolar encoding method and polar encoding method. Now in this lecture, I'll be discussing the third line encoding method, which is bipolar encoding method. Now, bipolar encoding method, like return to zero encoding method, it uses three voltage levels: positive, negative, and zero. Unlike return to zero method, here the zero level in bipolar encoding is used to represent binary zero. The binary ones are represented by alternating positive and negative voltages. If the first one bit is represented by the positive amplitude, the second will be represented by the alternate negative amplitude. Then the third binary one bit is represented by the positive amplitude, and so on. This alteration occurs even when the one bits are not consecutive. Now, this bipolar encoding method is categorized into three types: AMI, P8ZS, and HDP3. Now, in my further lecture, I will be discussing all three methods in detail. First, I will take bipolar AMI method, which is bipolar alternate mark inversion. It is the simplest type of bipolar encoding. In the word alternate mark inversion, the word mark comes from telegraphy and it means 1, whereas the word space in telegraphy means 0. So AMI means alternate 1 inversion. Zero voltage here is represented by binary 0. Binary ones are represented by alternating positive and negative voltages. Now we can explain this by giving a figure. Here in this figure, we can see we have sequence of bits here. 0 bit is represented by voltage level 0, whereas 1 bit is represented by alternating positive and negative voltages. Here we can see here 1 bit is represented by positive voltage, but the next 1 bit is represented by the negative voltage. Then the next 1 bit is represented by the positive voltage, whereas 0 bit is represented by the 0 voltage. A variation of bipolar AMI is called pseudo-ternary, in which binary zero alternates between positive and negative voltages. By inverting on each occurrence of a 1 which occurs in bipolar AMI, two things are accomplished. First, the DC component is zero because here both positive and negative voltage levels are used. And second, since ones are represented by alternating positive and negative pulses, so a long sequence of ones stays synchronized. However, in these methods, there is no mechanism to ensure the synchronization of long string of zeros. Now here we can see signals for both the methods AMI and zero-ternary method. In AMI, as already discussed, 0 is represented by 0 level and ones are represented by alternating positive and negative pulses. Whereas in zero-ternary, 1 is represented by absence of signal, whereas 0 is represented by alternating positive and negative pulses. So here we can see 0 is represented by positive pulse and the next 0 is represented by the negative pulse. Then next 0 is represented by positive pulse, whereas ones are represented by 0 voltage. These methods are used in DS1 and E1 lines. Now, to prevent the synchronization problem in case of consecutive zeros, two variations of bipolar AMI have been developed, especially for long distance transmission. The first method is used in North America, which is called bipolar 8-0 substitution, known as B8ZS. The second method is used in Europe and Japan, which is called high density bipolar 3, known as HDB3. Both are adaptations of bipolar AMI that modify the original pattern only in the case of multiple consecutive zeros. When more consecutive zeros are encountered in data stream, the solution is provided by forcing artificial signal changes called violations within the zero string. Now first, I'll discuss bipolar 8-0 substitution method. This method is adopted in North America to provide synchronization of long strings of zeros. In this technique, 8 consecutive zero-level voltages are replaced by the sequence 000V, B0, VB, where V represents the violation. This is the non-zero voltage that breaks the AMI rule of encoding, which is the opposite polarity from the previous one. And B is known as bipolar alternation, which means a non-zero voltage in accordance with the AMI rule. Now, this is described in the figure here. Here, two cases are discussed where first case represents when previous level is positive and the second case when previous level is negative. Now here we can see here one bit is represented by the positive level and there are 8 consecutive zeros. Now these 8 consecutive zeros is represented by the pattern 000VB 0VB. Now here we will see zeros, 3 zeros are represented by the 0 voltage. V means violation, that means it breaks the alternating polarity rule. So since the previous one bit is represented by the positive voltage, the violation bit is also represented by the positive voltage. Then we have B, which is bipolar alternation, which will follow the AMI rule. So it will be represented by the negative voltage. Then you have 0. Then we have again violation bit. So since the previous non-zero level is represented by the negative voltage, this violation bit is also represented by the negative voltage. Then B, which is alternation inversion bit, so it will be represented by the positive voltage. Similarly, we can see the signal in case when the previous level is the negative. So violation bit will also be represented by the negative voltage, then B will be given by the positive voltage, then 0 bit, then violation bit is again represented by the positive voltage because the previous B bit is represented by the positive voltage, and then the B voltage is given by the positive voltage. Now, this we can see the bits representation in case of B8ZS encoding. Here we have shown both the cases when polarity of previous bit is positive and the polarity of previous bit is negative. Here we have shown the violation bit also and the bipolar alternation also. So we can see I have marked it by violation bit 000V, then B0V. So this violation bit will violate the rule with this non-zero pulse. Similarly, here also this is the violation pulse which will break the rule according to this previous negative bit, and this violation bit will break the rule with respect to this positive pulse. Now, in this example, we will encode the bit stream here 1, 8 consecutive zeros, then 0, 0, 1, 0, 0. Here we have assumed that the polarity of the first one is positive. Now, here we can see polarity of first one is positive. So, since consecutive 8 zeros are used, so we will use the pattern 0, 0, 0, V, B, 0, V, B. So violation V bit is represented by the positive voltage because the previous one bit is represented by the positive voltage. Then we have B 0 VB. So it will follow B will have alternate polarity pulse, then 0, then again violation bit which will be again shown by the negative pulse because it is given by the violation pulse, then we have B. Then two zeros are represented by the 0 voltage. This one bit will be represented by the negative voltage because it is using AMI pattern. Since the previous non-zero pulse bit is represented by the positive voltage, this one will be represented by the negative voltage, and two zeros are represented by non-zero pulse. Now we will discuss high density bipolar 3 method. Here, this method is used when four consecutive zeros are encountered. This method is used in Europe and Japan. The pattern changes whenever there are four zeros in succession. Here, the four consecutive zero level voltages are replaced with the sequence of 00V or B00V according to the condition. The two rules can be stated below. If the number of non-zero pulses after the last substitution is odd, the substitution pattern will be three zeros and V, which makes the total number of non-zero pulses even. If the number of non-zero pulses even after the last substitution is even, the substitution pattern will be B00V, which makes the total number of non-zero pulses even. Now we will show this by example. Here, the if the number of ones since the last substitution is odd, then we have used the pattern 000V. So here we can see since the previous polarity is positive 000V. So V will be shown by the violation pulse. So it is positive. The violation pulse is also represented by the positive pulse. Similarly, in case of the previous negative bit, here it will be shown by the negative. Now in second case, if the number of ones since the last substitution is even, the pattern B00V is used. So here we can see if the previous bit is positive, B will be represented by negative pulse, then 0, 0, then V. Violation pulse will also be represented by the negative pulse because the previous non-zero pulse is negative. Similarly, here also, if the previous is negative, then B bit will be represented by positive pulse, then 0, 0, V. Violation bit also represented by the positive pulse. Now here we can see the working of HTP3 technique in case of sequence of bits. So here we can see that we have string of 1 and zeros, two ones, then we have four zeros, then 1, then we have more than 8 zeros. Here we can see that since the number of ones are 2 here, so which are even, so we will use the pattern B00V for these four zeros. So here B will be alternating pulse, then 0, 0 violation bit will be positive because the previous non-zero bit is represented by the positive pulse. Then we have 1, that means number of ones here are odd, So for substitution, we will use the pattern 000V. So 00V violation bit is negative because the previous non-zero pulse is negative. Then we have no ones here, so 0 ones are there, so we will take it as even number of ones. So the pattern which will be used for substitution is B00V. So here we have bipolar alternation bit, so which is shown by a positive because the previous bit is negative. Then 00V violation bit will be represented by the positive pulse. Now, in this example, we have applied HDB3 technique to encode the bit stream 1, then we have 8 zeros, 0, 0, 1, 0, 0. We have assumed that the number of ones so far is odd and the first one is positive. So for first one, we have taken the positive polarity. Then we have sequence of zeros. So we'll take group of 4 zeros. Now for first 4 zeros, we will use the substitution pattern 000V because it is given that the number of ones so far is odd. So 00V, V will be represented by the positive pulse because the previous one bit is represented by the positive pulse. Then for next zeros, we will take the pattern of even ones because here, since the last substitution, there are no ones, which will be taken as even ones. So B00V, so we can see B will be shown by the alternate negative polarity. Then 00V, V will be represented by again negative polarity because it is showing violation pulse. Then 00 is represented by 0 pulse. Then 1 is represented by positive polarity because it is following AMI rule and it will have positive polarity which is inversion of the negative polarity. So again 2 zeros which will be shown by the 0 voltage. Here we will have combined look at bipolar AMI, B8ZS and HDB3. In case of bipolar AMI, we can see that for a sequence of zeros, we have 8 zeros here. We have level which is not changing. So we will have synchronization problem here because receiver cannot detect where the first bit has ended and the second bit has started. So there will be synchronization problem in case of consecutive zeros in case of bipolar AMI. Whereas we have seen in case of B8ZS, because there are artificial signal changes which are called violation, the synchronization problem is solved here. Similarly, in HDB3 method, by using the substitution method, the synchronization problem as occurred in bipolar AMI is solved in case of HDB3. Now this is all for today's lecture. Thank you.